This is the 3.5 homework help video. We've actually been working on this assignment since Monday, and I've been telling you each day what section to work on. So you actually should have already completed numbers 1 through 8, and you're only working on 9 to the end. If you haven't noticed, the assignment is actually set up in the same order as the notes that we've been doing. So if you need an example for exercises 1 and 2, you want to look at your 3.5 day 1 notes, which we actually, let's not misspell day, which we actually took on Monday. Okay? There's also a 3.5 day 1 notes video already uploaded to Google Drive and YouTube if you need some extra support that way. Alright, so let's go ahead and jump into this assignment. I'm not going to do every problem with you, but I'll do one from each section. So notice right here it says in exercises 1 and 2, describe the slope of the line. So remember, we talked on day 1 about describe means to tell if it has a positive, negative, zero, or undefined slope. Remember, when we describe the slope, we're thinking about slope dude. Okay, so remember, slope dude helped us describe slope. Then we're going to calculate our slope. So remember, when they're asking you to calculate, so the calculate, that's when you're using y2 minus y1 over x2 minus x1, or you're using slope triangle to find the rise over run ratio, okay? And we watched several songs about calculating slope. We did the one that was the Gangnam Style. We had the one that you guys called the Bob Marley song, which was the one that says slope, it's the rise over the run, that one. So those two videos can help you if you need help with that. Okay, so let's go ahead and look at number 1. In order to describe the slope, I see that this line is sloping down from left to right. So think about slope dude. He's skiing down the hill, and he says, nice, negative, nice, negative. So I know that number 1 has a negative slope. That's description. The next thing I need to do is calculate my slope. So what I'm going to do is I'm going to put my pen on the leftmost point, and I'm going to count how many would I need to move down to get in line with that point. So I'm moving from here down to here. So that would be 1, 2, 3, 4. So down 4 would be negative 4 for my top number. Then how many would I have to go over to get in line with that point? So I would have to go over 1, 2, 3. So my run is 3. So my description is that the slope is negative, and then the calculation is that this has a slope of negative 4/3. Notice that if my slope is negative, meaning it slopes down from left to right, like this line, then the actual ratio should also be negative. Okay, go ahead and do number 2. So for this next section in exercises 3 and 4, they are telling you that the table, those points lie on a line. So they're already telling me that these are linear. Remember, on our review, we had a table and we had to tell if it was linear or nonlinear. And we talked about we need a constant rate of change in x and y in order to be linear. So I know there's a constant rate of change here, and that's called the slope. So I am going to calculate my slope. This is on the 3.5 day 1 notes if you need to review. But remember, you're going to be using the formula y2 minus y1 over x2 minus x1. So when we learned this, I told you guys, pick 2 points. It doesn't matter what 2 points, just pick 2. So I'm going to use these last 2. When you pick your points, the next thing you want to do is you want to label them. One of them will be x1, y1. So I'm going to write these. I have 4, 2 as one of my points. And I have 7, 3 as the other one. So I really encourage you guys to make sure that you label your points. So I'm going to label this one as x1, y1, and this one as x2, y2. Now I'm labeling my points because I have a formula right here that I'm going to substitute these numbers into. So if I know that this number is my y2, I am going to put it where y2 is in my formula. So I have 3 minus 2. That's my numerator because it's y2 minus y1. In my denominator, I have 7 minus 4 because that is x2 minus x1. Now I just do the math. So 3 minus 2 is 1, and 7 minus 4 is 3. Therefore, the slope of this line, which is number 3, is 1/3. Okay? All right, you should be able to pause and complete number 4. Okay, so 5, 6, 7, and 8, we initially started talking about this whenever we were doing the Find Someone Who activity on Tuesday. But then we went over it again today. So notice here it says that we are identifying the slope and the y-intercept of the graph of the linear equation. Those are the same exact instructions that I gave on the 3.5 day 2 notes, which we completed in class today. So day 2 was all about slope-intercept form, that y equals mx plus b. So in class today, we talked about that m is your slope. That's the coefficient of x. So the number that's being multiplied by x represents your slope. B represents your y-intercept. That's the constant. That means it's the number that has been added or subtracted to x. Now we watched 3 different videos that had songs, and most of you liked the one that said graph. So step 1 in that video, they kept saying get the y alone, get the y alone. So notice on 5, 6, and 7, y is already alone. On 8, you're going to have to get y alone yourself. And we did several examples of that on our notes today. I'm actually going to talk about number 6 because we talked about an example that looked like 5 on your notes. We talked about an example that looked like 7 on your notes. And we talked about an example that looked like 8 on your notes. The only one that we didn't talk about was one that looked like 6. So I'm going to write that down. I have y equals 7x. Now when you look at this equation initially, you should be thinking, yay, y is already alone. Which should be a good thing because today we talked about the first thing you want to do is make sure that it's written in the form of y equals mx plus b. This, I can see y equals mx, but I don't see a b value. But that's okay. If there's no b, that's like there's a little invisible plus 0. It's implied that the y-intercept is 0. So 7, because it's the coefficient of x, is my slope. We've been writing our slope as a ratio, so I know that whole numbers are written as 7/1. This plus 0, which isn't actually written, it's implied, but it gives me my y-intercept, which is going to happen at 0. So this line is going through the origin. Okay? All right, you should be able to use what I just talked to you about or your 3.5 day 2 notes to do 5, 7, and 8. Okay, so this next thing that I'm going to do is I'm going to help you review how to sketch the graph of the linear equation, and we're going to identify and label the X intercept. So if you look at your notes or you have your notes out, which you should, this is 3.5 day 2. That's what we did today in class. The main part of the notes and what we spent a ton of time doing was graphing. So I gave you 3 steps. So step 1 is to make sure your equation is written in the form of y equals mx plus b. Step 2 was to plot b. Step 3 was to rise and run your slope to get another point, and then we drew a line connecting those points all the way across our coordinate plane. So I'm going to help you with number 12 because this was the style that you guys had the most problems with today in class. You should be able to do 9, 11, and 10. Okay? So let's go ahead and look at number 12. First of all, it's not solved for y. So that's the first thing I'm going to take care of. So I'm going to subtract 4x from both sides in order to get y by itself. Now when I do that, those are going to cancel out, and I'm left with y equals negative 4x, and then I'm bringing down that positive 3. Okay? So now it's in the form of y equals mx plus b. I can now identify my slope. I see that m must be equal to negative 4 over 1, because right here, that's the coefficient of x. I see that b, which is your y-intercept, is equal to 3. Okay? So now I'm going to sketch a coordinate plane, and I'm going to follow my steps for graphing. Okay? So the first thing I'm going to do is plot b. I see b right here was equal to 3. So I'm going to go on my coordinate plane to 3, and I'm going to put a point on the y-axis at 3. Then step 3 is to rise and run the slope to find another point. So my slope right here was negative 4 over 1. So from the y-intercept, I'm going to go down 4. So 1, 2, 3, 4. And I'm going to go to the right 1. And I'm going to put a point. Okay, so I just went down 1, 2, 3, 4 over 1. And I put a point. Now I can draw a line through those points in order to get my line. Now my line is not very straight because I don't have a straight edge because I'm writing on my iPad. But today, remember, I told you, you can use the edge of your ID, you can use a note card, you can use the edge of a paper, anything straight to make a line that goes all the way across your coordinate plane. Now, the next part of this, though, is it asks me about that X intercept. And this is a great time to review how to find the X intercept. On this particular graph, I can't really tell where it's crossing X because I don't have an actual point there. So I'm going to go back to my original equation, which was 4x plus y equals 3. Now we just spent a ton of time, 2 weeks, on calculating intercepts. So remember, to find the x-intercept, all you have to do is plug in a 0 for y. Well, if I put a 0 right here for y, then that y is going to go away, and I'm going to be left with 4x equals 3. Then I'm going to solve for x. So I divide both sides by 4, and that tells me that my x-intercept must have occurred at 3/4, which is why I couldn't see it on the graph, because it was at a fraction. If you get a fraction, don't let that freak you out. Fractions are your friends. It's okay to have a 3/4 for your x-intercept. That just means that this crossed at 3/4. Okay? Alright, so you should be able to do 9, 10, and 11. Use your notes if you need help. Refer to the video if you need help with the notes. Okay, so we did a problem exactly like 13 on your notes. So I'm not going to work this problem with you. However, I'm going to get you started. Okay, so this is just like the last 2 problems we did on your notes. So this says a linear function f models a relationship in which the dependent variable, so remember dependent is your y, decreases by 3 for every 2 units the independent variable increases. Don't forget your independent is x. So we talked today about how they're giving me a change in my dependent compared to a change in my independent. Therefore, they're giving me change in y over change in x. That is slope. That is your rise over your run. So they're giving you your slope just in verbal language, okay? So a decrease, see it says decrease in 3 units, means -3 for every 2 units of increase in your independent. So I have now found m. I've found my slope. Then they're telling you the value of the function at 0 is 5. So they're giving me a point, 0, 5. Well, isn't 0, 5 a y-intercept? Okay, so I have M and I have B. You guys should be able to graph from that. Now today we took it a little bit further and we wrote an equation. So remember, y equals M, which in this case is negative 3 over 2, x plus b, which in this case is 5. So you should be able to write a linear equation if you know the slope and you know the y-intercept. Okay? So now you guys go ahead and graph that, and then you'll be done with this problem. Don't forget to go ahead and label your x-intercept of the graph like we did on your notes. Okay? So you have your slope, you have your y-intercept, you're going to graph, and you're going to find that x-intercept. This last problem is very similar to the problem I just went over with you. They're using that function notation language, which remember, the number in the parentheses represents your x value. This number represents your output or your y value. Okay? They are giving you your slope right here where it talks about the increase of 1.25 centimeters every month. So you guys should be able to graph and identify your slope and y-intercept. Now I noticed that, because I edited this to add in a graph, I noticed that right here I wrote inches. I would like that to be changed back to centimeters, okay, instead of inches. There's no need to do a conversion. So by how much in centimeters does the length of a hair stand increase each month? Okay? Alright, so you guys should be able to finish this homework up. If you have any questions, you can come in for tutoring. Really, I hope that you were able to get your questions answered in class today, or you're able to utilize your notes or this video in order to do this. But if you need help, I will see you in the morning. Have a great night.